in this video, we shall look at Venn diagrams, how we represent sets in Venn diagram. Venn diagrams are meant to show the relationship between sets. For example, consider set A that has 1, 2, 3, 4, and set B that has 2, 4, 7, and 8. 1. A intersection B is the set that contains 2 and 4 because 2 is in both sets A and B. And now to represent this in a Venn diagram, we need first to draw the rectangle. This rectangle represents the universal set, which we denote by writing an uppercase U somewhere at the corner there. Remember that the Greek letter Xi can also be used to represent the universal set. So where we have 2 and 4 is the intersection of A and B. And hence we can say that A intersection B is that part that I have shaded. A union B. A union B is you take all the elements in set A and all those elements in set B and you put them together. So ideally the two Venn diagrams will not look any difference, but what I want to emphasize here is that the shaded region represents A union B. A union B. The intersection is only this one, but the union is everything. Now, note that you can also represent the complement of A. That is the complement of A, and this is absolute complement. The complement of sets A. It is denoted like that. Some books write it this way, others like this. You can also read it as not A. Not A. These are the elements in the universal set and are not in set A. So if this is set A, then anything outside set A is what we are calling the complement of set A or not A. So this particular part is the complement of A, and this is A. You can go on like that and have, let's say, the difference of set A and B. The difference of set A and B. If we use the above examples, this is set A and this is set B, this is the set that contains the elements that are only in set A. The elements that are only in set A, which are 3 and 4. On a Venn diagram, this will be the shaded part. The part that I'm going to shade is the difference, set difference A, the relative complement, or the elements that are only in set A. We also have, let's say, set A, the symmetric difference of set A and B. These are the elements that are in both set A and B and not in the intersections. The elements that are in the two sets but not in their intersection. And this is the shaded part. This represents the symmetric difference of set A and set A and B. We can move on and maybe go to a situation where we have let's say more than two sets. For example, let us consider let's consider set A has the elements 1, 2, 3, 4, 5. Set B has the elements 2, 4, 6, 7, 8. Set C has the element 3, 4, 5, 9, and 10. How can we represent these three sets in a Venn diagram? Again, you need to draw the rectangle that represents the universal set, and then you draw three circles that are overlapping, or you can draw better circle than this. So let this be set A, this set B, this set C. So we want to represent these three sets in a Venn diagram. What you should do is always start at the center. Here, this part, the center. This is the element that appears in all the sets. And you'll see the elements that appear is 4 is in set A, 4 is in set B, and 4 is in set C. So we write 4 here. Okay? Then we can write what is here. This element is only in set A and B, but not C. A and B, but not C. And this element is 2. 2 is only in set A and B. Set A and B. Actually, we can say that A intersection B intersection not C is 2. And 4, where we have 4 is A intersection B intersection C, is the set that contains only 4. You will notice that the elements that are in A intersection C and not B, the elements or the element that is in A intersection C and not B, that is, you can only find that element in A and C, and that element is 5. So here we have 5. We can also say that B intersection C and not A, which element is in B and C and not A. And you'll notice that I think 3 is also in 3 is also in A intersection C and not B. We have 3 and 5, sorry for that. 3 is also in A and also in B. So 3 here, 3 is also in set C. But when you look at set B, 6 is not in A, it's not in C. 7 is not in A and it's not in C. 8 is not in A and it's not in C. Therefore, this set B intersection C is empty. B intersection C is empty. This area is empty. This one is empty. B intersection C and not A is empty. And therefore, you find that 9 and 10 are only in set C. Set C only. Set B only, we have 6, 7, and 8. Set A only, we have 1. That way we have represented those three sets in a Venn diagram.